In this chapter, we'll go over benzene and its properties. Benzene is the simplest aromatic hydrocarbon. We will define the term aromatic as we go. It is highly unsaturated. It has 3 double bonds in the cycle. This is why its TBE is 4. It undergoes resonance with the moving of electrons, and benzene normally is represented by its hybrid. If we look at its bonds, benzene is made up of an alternation of a double and a single bond. Because it undergoes resonance, all its bonds, they are the same, and they do have the same length. Their length is between the single and the double bond. All the carbons of the benzene are sp2 hybridization. This means that every single carbon has a p orbital with 1 electron. These p orbitals overlap with each other above the ring and below the ring. So they create an electronic cloud, which makes benzene electron rich. This is why benzene is considered to be a nucleophile. So that is going to be a nucleophile in there. Each of the benzene hydrogen is connected to an sp2 hybrid carbon. That makes the sigma bond a strong bond, and this hydrogen can never be taken by a base. This is why all of the hydrogens of the benzene are not treated as an acid, and benzene is not an acid. Benzene is a nucleophile. It is electron rich because of the electrons on its p orbital in there, and it is very reactive with the strong electrophiles. To name benzene derivatives, if you have one substituent on the benzene, it depends on the actual substituent. So for some substituents, you name the substituent and you put the word benzene at the end. For other substituents, and I've listed them all over here, you name the substituent and the benzene. We call this a common root, and you put the name at the end, which is a parent name. So here, the name is going to be, instead of methylbenzene, you name it as a whole. This is the common root, and you name it as toluene. And this goes at the end of the name. All of these, they are common names. They are not IUPAC names. And we go by their common names. We don't go by the IUPAC name. So an OH connected to a benzene, this is called a phenol and not a hydroxybenzene. Same thing for aniline, benzaldehyde. The term benz, we use it whenever you do have a carbonyl that is connected to the benzene. And then whatever comes after the benz will define the functional group. So if it's an aldehyde in there, then you have an aldehyde. If it is an oic acid, then this is going to be a carboxylic acid. Anisole is methoxybenzene, but we don't go by methoxybenzene. Whenever you have just one substituent in there on the benzene, we go by anisole. Same thing for styrene and acetophenone. Acetophenone is a ketone, and the term acid, we use it for the carbonyl that is connected to the CH3, so this is going to be the acid group. The phenyl is the benzene, and then the ONE is the ketone. For disubstituted benzenes, we use the terms ortho, meta, or para. Ortho means positions 1 and 2 are occupied, meta positions 1 and 3, and para positions 1 and 4. You can either write the word ortho as is, or you abbreviate it as an O. Same thing for the meta and the para. We always use these terms whenever we have only 2 substituents on the benzene, not more than 2 substituents in there. And then you always alphabetize your substituents and put them in alphabetical order. Number. Bromine comes before chlorine. This is why we start numbering from the bromine in there. We don't use 1, 3, we use the meta. Whenever you have any of those substituents on the benzene, we are going to use a common root that ends the name instead of ending the name with the benzene. The priority of these groups is the following. So the acid has a higher priority in naming than the aldehyde, then the OH, then the NH2, then the methyl, then the NO2. For example, if you have a carboxylic acid and an OH on the benzene, then the name will be ended in benzoic acid instead of a phenol. So for example, if you have a CH3 connected to the benzene, then in this case, you're going to name it as a toluene and you're going to put it at the end. Bromine is on position number 4, so this is going to be para-bromo-toluene. You don't name it as a para-bromo-methylbenzene. This is not the right way to do that. Same thing between an OH and an NO2. The OH has a higher priority in the naming. So your ending is going to be a phenol in there. OCH3 and the bromine, the OCH3 is going to have a higher priority, so the name is going to end in anisole. Next to the oxygen. Now, if the R next to the oxygen is more than one carbon, then you're going to name it as an alkoxy derivative. Something like this over here. So if you have a benzene, if you have an oxygen that is connected, let's say, to a propyl group and a bromine, then you list that in alphabetical order, because this whole thing now, you're going to name it as an alkoxy derivative. Bromine is on the second carbon. You list those in alphabetical order. So the name is going to be an ortho bromo. You start with the bromo, and then you name it as a propoxy benzene. The number around the ring. If you have 3 or more substituents, don't use the orthometa and para. You have to give the substituents the lowest number around the benzene. And if you are using a common root, you have to start numbering from that common root and give it the lowest number. And then go by the direction to give the second substituent the lowest number. So this one over here is aniline. You start numbering from the carbon. We're going to move this way because the second substituent is closer to the aniline. So to give all the substituents the lowest number possible. If you have something like this, you don't have a common root in this case. Then your ending is going to be the benzene, just the benzene. And you list the substituents in alphabetical order and you give them the lowest number possible. This is why you always start with the substituents that are closer to each other in there, and then try the direction that gives the lowest possible number in there. So here I'm going to start with carbon number 1 instead of starting from carbon number 1 from there, because if you start from 1 here and you go up, then this is going to be 1, 2, 3, 4, and 5 instead of 4. So you're going to end up having more numbers for your substituents. If you have a hydrocarbon on the benzene, then in this case, if the number of carbons of the hydrocarbon is less than the number of carbons of the benzene, then benzene is going to be a parent name and it goes at the end. So that is going to be named now as a propyl benzene. However, if you have the number of carbons of the chain on the benzene more than the number of carbons of the benzene, then your ending needs to be in that chain. So let's say, for example, if I have something like this over here, that is going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So your ending in this case is going to be nonane. And you give your benzene the lowest number. So it's going to be 2-phenyl nonane. Now, if you have a degree of unsaturation that is a substituent on the benzene, you cannot end the name with the benzene. You have to end it with the degree of unsaturation. This is an alkene, so your ending needs to be an alkene. You choose the longest carbon chain that has the double bond. You cannot choose the 4-carbon chain in here and leave the double bond, so you have to choose this route over here. Don't forget, there is a stereochemistry around the alkene. You start numbering by giving the double bond the lowest number. So this is going to be 1, 2, 3, and 4. This is an E stereoisomer because you do have your benzene and your ethyl group as a higher priority, and these are on opposite sides. So we're going to go ahead and do E. We don't need to do one E because your double bond here, in this case, it is on carbon number 1. So that is going to be E, and the benzene now is going to be a substituent that you're going to name it as a phenyl. Arrange it in alphabetical order, all the substituents. So that is going to be an E. It's going to be a 2-methyl 1 phenyl beauty. Okay. There is a difference between a benzyl and a phenyl group. A phenyl is a benzene that is connected to a substituent. A benzyl is a benzene that is connected to a benzylic carbon. So in this case, you name it as a benzyl and then you name the substituent.